Hello friends, welcome back to MeshMind. In today's video, we are going to learn everything about 8051 microcontroller. Whether you are just starting with microcontrollers or revising for an exam, this video will help you understand the 8051 in a clear and simple way. So let's begin. So first, we will see what is the 8051 microcontroller. The 8051 microcontroller is an 8-bit microcontroller originally developed by Intel in 1980. It is one of the most popular and widely used microcontrollers in embedded systems. It has built-in ROM, RAM, input-output ports, timers, serial communications, and more, all on a single chip. This makes it ideal for small control-based projects. Then architecture and block diagram of 8051. The internal architecture of the 8051 microcontroller includes several important blocks. At the center, we have the CPU, which controls all operations. It connects to the program memory ROM and data memory RAM. It also includes I/O ports P0 to P3 for input and output operations, timers and counters for timing and counting external internal events, serial communication block for UART based communication, interrupt control for handling external or internal interrupt signals, special function registers to control specific function. The block diagram helps us visualize how all these units are connected internally to work together. Then pin diagram of 8051 microcontroller. The 8051 microcontroller comes in a 40-pin dual inline package DIP. Each pin has a specific role. Let me explain the important pin categories. Pin 1 to 8 is port 1, used for general purpose input output. They do not have alternate function. Pin 10 to 17 is port 3. They are also input output pins but have alternate functions like serial input, output, external interrupt, timer, etc. Pin 21 to 28 is port 2, general purpose input output pins and can also be used as higher address bus line in external memory interfacing. Pin 32 to 39 is port 0. This port is dual purpose. It works as input output and during external memory access it also acts as data and address lines multiplexed. Other important pins. Pin number 9, reset pin. A high pulse on this pin reset the microcontroller. Pin number 18 and 19, XTAL1 and XTAL2. These connect the crystal oscillator which decide the system clock. Pin 20 is ground. Pin 40 is VCC power supply, typically plus 5 volt. Pin 29 PSEN program store enable, used to read external program memory. Pin 30 ALE address latch enable, used to demultiplex the address or data bus. Pin 31 EA external access. If connected to ground, the controller uses external memory. Then specifications of 8051. Here are some technical specifications of the 8051. 8-bit processor, 4 KB of ROM on chip, 128 bytes of RAM, 32 input-output lines divided into 4 ports, 2 timers or counters, 1 serial port, 6 interrupts including reset. Clock frequency is 11.0592 MHz, commonly used. And timers and counters. The 8051 has two 16-bit timers or counters, timer 0 and timer 1. This can operate as timer to count internal clock pulses or as counters to count external pulses. They are used in applications like delay generation, waveform generation, or measuring events. In interrupts in 8051. Interrupts allow the microcontroller to pause the main program and execute a special function called ISR, interrupt service routine, when an event occurs. 8051 supports 6 types of interrupts: external interrupt 0, timer 0 interrupt, external interrupt 1, timer 1 interrupt, serial communication interrupt, and reset interrupt. Interrupts increases the efficiency of the microcontroller by responding only when required. And registers in 8051. Registers are small memory unit inside the CPU for temporary data storage. The main ones include accumulator, used in most arithmetic and logic operation. B register, often used in multiplication and division. Program counter, holds address of next instruction. Stack pointer, points to top of the stack. Data pointer, used for accessing external memory. Then special function registers, SFRs. SFRs are special registers that control specific function like timer, input output, serial, etc. Some example: TCON, timer control, TMOD, timer mode, IE, interrupt enable, IP interrupt priority, SCON serial control, P0, P1, P2, P3 port registers. Each SFR is assigned a unique address in memory. Then IO ports port 0 to port 3. Detailed explanation. The 8051 has 4 ports, port 0, port 1, port 2 and port 3. Each port has 8 bit wide and all port can be used for input and output. Port 0 P0.0 to P0.7. This port has dual functionality. It can be used for generally input-output or for external memory interfacing as both addressing and data lines. It does not have internal pull-up registers, so external pull-ups are needed. Port 1 P1.0 to P1.7. This is dedicated input-output port. It has no alternate function and comes with internal pull-up registers. It is the simplest to use. Then port 2 P2.0 to P2.7. Similar to port 1 is normal mode, but during external memory access it is used as the higher order address bus A8 to A15. Also has internal pull-ups. Then port 3 P3.0 to P3.7. This port is multifunctional. Apart from general input-output, each pin has a special function. P3.0 serial input, P3.1 serial output, P3.2 external interrupt 0, P3.3 external interrupt 1, P3.4 timer 0, P3.5 timer 1, P3.6 external memory write, P3.7 external memory read. Then crystal oscillator in 8051. The 8051 uses an external crystal oscillator to generate clock signal for its internal operations. The most common crystal used is 11.0592 MHz. It allows standard serial communication baud rate like 9600 bps. So that was a complete overview of the 8051 microcontroller, from its architecture to pin diagram, memory, timers, interrupts, ports and crystals. We have covered it all in a beginner friendly way. If you found this video helpful, don't forget to like, share and subscribe. In the next video, we will take this knowledge and write our first real program like LED blinking. See you in the next video. Happy learning.